Hi guys, and welcome to your first Chem Talks from Mr. J. Today we're going to start our investigation into chemistry talking about matter. Before we get going, I want to remind you of a couple of things. As you go along through this podcast, please make sure that you are taking good notes. Stop, pause the video whenever you need to make sure you're getting everything. If you forgot something or didn't get it, go ahead and rewind it. Alright, with that out of the way, let's go ahead and start talking about matter. To do that, let's start first by defining chemistry. Chemistry is simply the study of matter, or in a little more scientific way, we can say it's the study of the composition and properties of substances and the changes that such substances can undergo. So we're looking at different types of matter, looking at different types of atoms and elements, and not only are we looking at them as individuals, but we're also looking at how they can change. So let's look at matter. Matter we can define as anything that has both mass and volume. Well, what's mass? Mass is simply the amount of matter in an object. I know it's kind of weird to define matter by saying it has mass and mass is matter, but just work with me on this one, okay? So mass is a constant value. No matter where something is, its mass is constant. It's the same. Volume, on the other hand, you should be familiar with. Volume is simply the amount of space that an object takes up. How much area does it occupy? Now, oftentimes we use the term mass and weight interchangeably, okay? But what we need to understand is that they are actually two different things, okay? Mass is something that is always part of an object. No matter where you go, it's relatively the same. I say relatively, if you're on a diet, you lose some mass when you diet. But if you measure your mass at different places at different times, okay, it's going to be constant. Now, weight, on the other hand, depends on gravity. So if we measure your weight at the equator and go up to the North Pole where the gravity is slightly different, you'll see a difference. Or if we go out in outer space where there's hardly any gravity, we'll see a big difference. So weight is simply the measurement of the force of gravity acting on the mass of an object. Okay, it's not constant. It changes with location, which has to do with the effect of gravity on it. Okay, so weight does change with gravity. So if we look at this, for example, here on Earth, okay, we have a mass of 100 kilograms and a weight of 980 newtons. Don't worry about newtons, just understand it's a measurement of weight. If we go up to the moon, then what we see is our mass is the same at 100 kilograms, but our weight is now at 162.2 newtons. Okay, so weight changes, but mass does not. It's constant. Okay, when we talk about matter, we often talk about the states of matter. And you can probably name the three common states: solid, liquid, and gas. Okay, so a solid state of matter is matter that can't flow. It has a fixed shape, okay, and has a definite volume. Liquid, on the other hand, think about a water bottle, right? It has a definite volume, but it can flow. It can change to match the shape of its container. And then the third one is gas, okay? Gas is a substance that doesn't have definite volume or shape. It has a tendency to expand to fill whatever container it's in. So the volume changes and the shape changes. One thing that we often talk about when we talk about gas is something called a vapor. And a vapor is a substance that's currently a gas, but normally at room temperature it's a liquid. A good example would be water, right? When we heat water up, we form water vapor. Or mercury. Think about mercury, right? At room temperature it's a liquid, but we can heat it up and make mercury vapor as well. So three basic states are solid, liquid, and gas. But if we look at them, a real summary here, we can see solids have definite shape, definite volume. Okay? The particles are packed close together. Liquids, on the other hand, they have an indefinite or changing shape, but a definite volume. Okay, and particles are getting a little farther apart. And then finally, in gas, it doesn't have a definite shape or volume. It's changing. Okay, and the particles are very far apart. We'll talk about why the particles are differently spaced in future units. For right now, just understand it has to do with the amount of energy. So these are our three most common ones. But what we do is there are actually more, right? You've probably heard of plasma. Maybe you have one of these plasma balls at home. Or you've seen or heard about the northern lights. Okay, this is an example of plasma. And plasma exists at high temperatures in relatively low pressure environments. Okay, like a gas, it lacks a fixed volume and fixed shape. Okay, what we see going on though in a plasma state is electrons, which we haven't talked about, but you should know what they are from past science classes is they have a tendency to separate from the nucleus. Well, when this happens, it allows the plasma to conduct electricity and respond to magnetic fields, something that gases cannot do. Okay, so plasma is another state. We're not going to spend too much time on it, but I do want you to make you aware of it since you do hear of it quite often. When we talk about matter, we need to talk about the properties of matter. Okay? Chemists use these properties to tell different substances apart. What's the difference between gold and silver, or gold and lead, and why can't we change from lead to gold? Okay? It has to do with its properties. So right here we have two different substances that look relatively alike, but they probably have different types of properties which distinguish them from each other. So the first type of properties we're going to talk about are physical properties. And physical properties are characteristics that can be observed or measured without changing the identity of the substance. So we start with something and end up with it exact same. Okay? Examples of this could be the melting point, the boiling point, or also the freezing point of an object. Okay? Think of water. Water, whether it's solid, liquid, or gas, is still water. Okay? We can look at the density, which we'll talk about here in a later one. But density is basically how tightly packed the molecules are to each other. We can look at the color of a substance. We can look at, is it conductive? Does it conduct heat? Does it conduct electricity? And these are all things that we can observe without changing the substance. We also talk about physical changes. Okay, this is a change that occurs in a substance that doesn't change identity, just like a physical change. Okay, water, we can go from a liquid to a gas and it's still water. Okay, we can change the shape of something, right? We talked about water has a changing volume, but still water. We can change size. Picture I have a piece of paper, I tear it in half, now I still have paper, it's just too small a size. We can look at the change of the phase, the change in state, which we already talked about. The next one is that we talk about is whether it's an extensive or intensive property. An extensive property, it depends upon the amount of matter that we have. So examples could be the volume, the mass, the amount of energy that something contains. That's going to depend on how much of it is. The other type is what we call an intensive property. In an intensive property, it doesn't depend upon the amount of the substance. It's going to be constant. Things like the density, the boiling point, the ability to conduct, what color is it? Does it have an odor? Is it luster? Does it shine? Is it malleable? I mean, can we flex it? Does it conduct electricity heat? Those are all things that don't depend on the amount of it. Like extensive depends on the amount, intensive does not. The other property that we talk about besides physical is chemical. In chemical properties, what we can see is that we only observe these properties by changing it into a different substance. So in the end, after we observe these, we end up with a brand new substance. Okay. Easiest way to see if it's chemical properties is see it when it's reacting with something else. Okay. Examples include the ability to burn. Think of it, you're out in summer, you're burning a log. Okay, put in your fire, get up in the morning, that log's gone. You no longer have the wood. Right now you have carbon. That's an example of combustion. Okay, silver. Maybe you look, mom's good silver, right? You take it out once a year and you have to shine it up because it has tarnish. That's an example of a chemical property. Ability to rust, right? Rusting is taking metal, iron, and exposing it to air, oxide, okay? And we end up with iron oxide, which is oxidation. Okay, the ability of things to decompose, or the ability to react with other chemicals. These are all chemical properties, and remember, we end up with something new or different than what we started with. We can also look at chemical changes, which are very similar to chemical properties. Okay, so once it's a change that something undergoes, and once again it's converted into a new substance. Okay, it occurs when a chemical reaction causes bonds between atoms to break or form. Remember, bonds are the things that hold these different particles together. Okay, so when they break or they form, we get new substances and new properties. Okay, in a chemical reaction, what we start with we call the reactants. Okay, what we form in the case of chemical properties, it can be a new substance. We call those the product. So, what evidence do we have of chemical change is going under? Well, what we can see, these might include things like a color change, okay, an odor change. We form a gas. We form a precipitate. If we look over here, we're mixing a liquid with liquid, and we end up, in this case, with a yellow precipitate. So a precipitate is a solid that forms as a result of a chemical reaction. Gas, maybe you've done the experiment where you combine vinegar and baking soda, right? The classic volcano experiment. One of the byproducts you get that makes it foams up is carbon dioxide, which is a gas. Okay? Maybe we're going to get some changes in the physical properties as well. As we form a new substance, it takes on new physical properties. Okay, a couple examples we've already talked about. Rusting, we said it's iron oxidizing, changing to a new substance, iron oxide. Fireworks, there's a great example, one of my favorite examples of chemical changes. Color change, light, heat, energy. We talk about leaves changing in the fall. That's an example of them undergoing chemical changes. And we already said a precipitate, when we form a solid. So, now that we know about the physical and chemical properties of matter, we can begin to classify it. And basically there's two general categories that we're going to start with. The first is a pure substance. And a pure substance is a substance made up of only one type of particle. Okay? Versus a mixture, which is a substance made up of two or more pure substances that are in the same place. Okay? But each of these substances, when they're combined, keep their individual properties. So let's look at pure substance a little more. The most simplest pure substance is what we call an element. And an element is a substance made up of only one type of atom. A good example of that is gold, silver, or my favorite element, titanium. Okay, a compound, on the other hand, is a substance that are made up of two or more elements that are in a fixed ratio and they're chemically combined. Okay, what we see is in compounds, the property of that final compound is different from individual elements. A good example of this is sodium chloride. Both sodium and chloride by themselves are pretty hazardous. We put sodium in water, it explodes. We know chlorine's pretty nasty. We use it to clean our swimming pools and stuff like that. But when they combine, they form a relatively harmless substance called sodium chloride, or table salt, which we use on a lot of our food. Okay, so what we see is in a compound, these two or more elements are coming together and being held together by these chemical bonds. Talked about sodium chloride. Another example there is magnesium dioxide. When we talk about pure substances, we often talk about what we call the law of definite composition. The law of definite composition says this, that a given compound always contains the same fixed ratio of elements, meaning water has a chemical form of H2O. Sodium chloride, a table salt, is always NaCl. Let's take a look at two different compounds here made up of carbon and oxygen. The first one here is carbon monoxide, made up of one carbon and one oxygen. The other one then we have is carbon dioxide, made up of one carbon and two oxygen. Even though they're made up of the same compounds, they're found in different ratios. Okay, and they're very different for us, right? Carbon monoxide, if we breathe enough of it in, will kill us. This is carbon monoxide poisoning. Carbon dioxide we're producing every time we breathe out. Okay? So law of definite composition that says that a compound is always made up of the same atoms in the same ratio. So two different compounds, each has a definite composition. Okay, the other category then is what we call mixtures. Mixtures are a physical combination of two or more substances. Okay? They have variable composition. They're not fixed like we see in pure substances. Okay? And what we see is that the components can be separated using some sort of physical mean. So when these things come together, they retain their original properties. A couple good examples here. The first type is what we call heterogeneous mixture, which we can see an example of this rock here. In a heterogeneous mixture, what we see is that there are two or more visibly distinct parts. Okay, we can see the different parts in their rock sample there, and each part has its different properties that it retains. The other type here, with our Kool-Aid, is going to be a homogeneous mixture. In a homogeneous, what we see is the parts are evenly mixed. We can't see the different parts. They look the same throughout. Okay, so it also has the same properties throughout the substance. So two categories of mixture. Heterogeneous, where we see different parts. Homogeneous, where it looks the same throughout. Now, with mixtures, we can generally physically separate them. Okay, unlike pure substances. So one way we can do this is to use filtration. Think about pouring a substance through either a filter, maybe like cheesecloth. We can separate the different parts of it. Okay, we can also use distillation, okay, to separate more liquids with different boiling points. So we heat it up, and what we see is some substances boil off early at a lower temperature, some boil off later at a high temperature. This is how we make a lot of our petroleum products. Right? We don't just get crude oil out of the ground and put it into our cars. No, we distill it into gasoline and other byproducts. And then the third product, or third separation, is what we call chromatography. And we use this to separate out liquids or solutions of compounds. Alright, let's kind of organize our thoughts around matter. So when we're trying to classify matter, first thing we should ask, can it be physically separated? Okay, if our answer is yes, then we know we're talking about a mixture. Okay, then we ask, well, is the composition uniform, or does it look the same throughout? If it does look the same throughout, we're talking about homogeneous mixture. If we can see different parts, then it's a heterogeneous mixture. But what if we can't separate them? Okay, well then it must be a pure substance. And can it be chemically decomposed? That means, is it made up of two or more atoms or only one? Well, if it's made up of more than two or more atoms, we say it's a compound, carbon dioxide, sodium chloride. If it's made up of only one atom, then it's going to be an element such as gold, silver, titanium, oxygen, all those good things. Alright guys, thanks for sticking with me on matter. If you missed any part of it, please go back in your notes and review, okay, get anything you missed, and we will talk about this in class tomorrow. If you have any questions though, please come see me. And until next time guys, take care.